Now, chemical bonding. The first thing you need to know is what chemical bonding is. Chemical bonding is just a joining of atoms to make a chemical compound. Now, in chemical bonding, you are not mixing these molecules because there is a difference between a mixture and a compound. A mixture, you are just going to get atoms, you put them together. For example, you are going to get sodium atoms, you put them together, oxygen atoms together, chlorine atoms together, and like that. You can have, say, for example, a mixture of salt and water. That is a mixture, and that is going to form what we call a solution. So every time you have got water and something dissolved in it, that can dissolve, that is a solution. A mixture of water and sand is not a solution because sand can't dissolve. Now for a compound is not a mixture. You have to have atoms which have reacted. For example, you mixed sodium and chlorine. These two, they don't just become sodium and chlorine together, no. They form one compound, sodium chloride. So sodium alone is harmful. Chlorine alone is harmful. But sodium chloride is not harmful. It's actually the salt that we use. So a compound is formed as a combination of two molecules, and then you end up forming a totally different molecule at the end. So when you're talking about chemical bonding, there are two basic types of chemical bondings. We have got ionic bonds. Now ionic bonds, these are going to be formed between a metal and a non-metal. That is the first thing. Non-metal and a metal. Very important here. Another thing you need to know about an ionic bond is that when this non-metal and the metal they are getting to react, this is going to involve the gaining and losing of electrons. Okay, so one compound is going to be gaining and the other one is going to be losing electrons. Another thing you need to know is that this is not a mere gaining and losing of electrons. Metals are the ones which lose electrons. And remember from the previous class which you had said that compounds which lose electrons become positively charged. So metals are going to be losing electrons, and so they are going to be becoming positively charged, and non-metals are going to be able to gain electrons, and so non-metals will become negatively charged. So metals form cations, non-metals form anions. So this is the basic that you need to know about ionic bonding. The other type of bonding is known as a covalent bonding. Now when you're talking about covalent bonding, this one is going to be between non-metals. You don't have a metal in covalent bonding, only between non-metals. And this one doesn't involve losing and gaining of electrons. Instead, it involves the sharing of electrons between non-metals. And so there is nothing that is going to be positive and there's nothing that is going to be negative because you are just sharing electrons between non-metals. So if you check the way the periodic table is given, it's something like this. There is a point on the periodic table where you can differentiate non-metals from metals. So somewhere here there is a zigzag line that you can draw. So everything this side, these are going to be non-metals, and then this side these are going to be metals. Okay, this is how you can divide metals from non-metals. Now let's start with covalent bonding. Remember, covalent bonding is the sharing of electrons. Let's say, for example, they've asked us to draw the molecule for hydrogen. How do you draw it? The first thing is you need to know each one of the atoms. So in hydrogen, we have got two hydrogen atoms, and you need to know the electron configuration for each hydrogen atom. Now, hydrogen has a proton number of 1, meaning that the electron configuration is just going to be 1. It just has 1 electron. So meaning that this is going to be hydrogen with an electron here, is going to be able to react with another oxygen and another hydrogen. This is another hydrogen here, and it also has an electron. You can see, remember we said that hydrogen and helium, they are in group 1. So for them to balance, they are going to have 1 electron in the outermost shell. Okay, 1 electron in the outermost shell. So this is how this one, I've said 1. So hydrogen and helium, they balance when they attain duet, and duet is having 2 electrons in the outermost shell. So you can see this one has got 2 electrons, even this one, because those 2 electrons are for both atoms. So this is the molecule for hydrogen. Let's say we want to write the molecule for oxygen. Now oxygen again has got a proton number of 8, meaning that the electron configuration, what will be the electron configuration for oxygen? Are you able to tell me? So it is 2, 6. Okay, so that will be the electron configuration for each oxygen, but this is O2, meaning that you have got 2 oxygens. So one oxygen, the configuration 2, 6 means that it has got 2 shells. The inner shell has got 2 electrons, like that, and then the outer shell is going to have 6 electrons. I'm going to draw another oxygen molecule. It has got an inner shell which is going to have 2 electrons. For this one, let me use a dot, and then an inner shell which is going to have 6 electrons. Now when you look at your periodic table, oxygen is in group 6. Okay, let me make it a bit bigger. So we have got atoms, we have got group 1, group 2, group 3, group 4, group 5, 6, 7, 8. Let me start from group 5. In group 5 we have got a nitrogen there. In group 6 we have got oxygen. Group 7 we have got a fluorine at this point. And then we also have group 8. On top here we are going to have helium, and then on top here we are going to have hydrogen. Now hydrogen can be placed here, it can be placed here, depending on the periodic table that you are using. It just means that it transitions, it can act as donating electrons or accepting electrons. So there is something which is known as valency. Valency is just a combining power of an element. You have got valence electrons. If you say valence electrons, you mean electrons in the outermost shell. Now valency is the combining power of an atom. So what you do is that group 1 atoms, they've got a valence of 1. Group 2 atoms, a valence of 2. Group 3, a valence of 3. Group 4, a valence of 4. When you go to group 5, instead of having a valence of 5, you'll be subtracting from 8. So group 5, they've got a valence of 3 because it's 5 minus 8, or 8 minus 5. Group 5, 6, I mean, I've got a valence of 2 because it's 8 minus 2. Group 7 have got a valence of 1. Group 8 is 8 minus 8, they've got a valence of 0. That's why we call them noble gases or inert gases, because they don't react. So these atoms which are in group 6, because I've got a valence of 2, they can form two bonds. Okay, two bonds. That is very important for you to understand. And then those in group 5, they've got a valence of 3, they can form three bonds. Okay, those in group 4, they have got a valence of 4, they can form up to 4 bonds if reacting with themselves, like when a carbon reacts with itself. So already this tells you oxygen is in group 6. So how many bonds can oxygen form? How many bonds since it's in group 6? So the electron configuration is going to be 2,6. So oxygen, because it's in group 6, it will be able to form two bonds, meaning a double bond. So the molecule for oxygen is written like this: oxygen bonded to oxygen, like this. There's a double bond. Okay, so now let's write the molecule. So we are going to have the innermost electrons like this, the innermost shell with 2 electrons, and then the outer shell. And then you are going to have another oxygen, the inner shell, which has also 2 electrons, and the outer shell. So when you are forming a double bond, remember the outer shell has got 6 electrons. So always put first 2 electrons here. Put 2 electrons here, and then you are remaining with 4. So those 4 electrons which are remaining, I'll put 2 here, and then I'll put 2 here. And then for the other oxygen molecule, I'm going to write 2 electrons here. And then the other 4 which has remained, I'll put 2 here, and then I'll put 2 here. Now we need to make sure that we count each oxygen should have 8 electrons in the outermost shell. So for this one, 1, 2, 3, 4, 5, 6, 7, 8. That will also be the same one with the one I've drawn in green. So now each oxygen has got 8 electrons in the outermost shell. You can see these 2 electrons. This is a bond. These 2 electrons is a bond. This is what forms a double bond between each oxygen molecule. Is that okay? Okay, good. So you need to make sure that you know this structure, because they can ask you to draw. And then let's do the one for nitrogen. So nitrogen is in group 5. It has got a proton number of 7, meaning that each nitrogen molecule, the electron configuration is going to be 2, 5. Now remember, we said that those atoms which are in group 5, what is their valency? Is 3 electrons in the outermost shell. So meaning that nitrogen can form even 3 bonds when it is reacting with itself. So we are going to have the first shell. Mostly they can even ask you to say just show the outermost shell. So you only show electrons in the outermost shell. Don't show what is inside. So I'm going to write the first atom like that, and then the second atom like that. Now because this one has a triple bond, and nitrogen actually has a triple bond, okay, so it's going to form 3 bonds between each of these 2 atoms. So what we are going to do is that for the first of nitrogen, it has got 5 electrons in that atom shell. I'm going to put 3 here, 1, 2, 3, and then the other 2, let me write them here, 1, 2. So that forms 5 electrons. Always put 2 inside like that. And then for the other nitrogen, I'm also going to put 3 here, 1, 2, 3, and then the other 2, put them outside here. So each one of this, I'm only showing the outermost shell, I'm not showing this. If I want, I can put that inside with 2 electrons, and then here also with 2 electrons, but I'm not showing the outer shell. So let's count. We see how many electrons are in each atom in the outermost shell. So this one has got 1, 2, 3, 4, 5, 6, 7, 8. So you see that it has got 8. That will be the same with the other one. So this is the structure for nitrogen. It has got a triple bond. A single bond is here, another single bond here, another bond here. There are 3 bonds, so that forms a triple bond which is found in nitrogen. Does this make sense? Okay, let's draw now the structure for water. Now water is made up of hydrogen, 2 hydrogens with 1 oxygen. Because you have got 1 oxygen, you always write 1 oxygen, and then the 2 hydrogens will be on each end. So water only has single bonds. Remember, oxygen, the electron configuration is 2, 6, and then hydrogen, the electron configuration is just a 1. Okay, so this will mean we are going to have the oxygen. I'm only going to show the outermost shell, only this one with 6 electrons, and then we have got 2 hydrogens, 1 hydrogen this side, 1 hydrogen this side. So each one of these hydrogens is bringing each 1 electron, so it will bring 1 electron. Even this one will bring 1 electron. And then for the oxygen, it has 6 electrons. 1 electron will be here, 1 electron will be here, and then we are remaining with 4. I'll put 2 here, I'll put 2 here. So when you're writing these structures, you need to write a key. This means that the star or times is representing electrons for oxygen, and then a dot is representing electrons for hydrogen. So if you count oxygen, the electrons in the outermost shell, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 electrons, and that means that oxygen is stable. Hydrogen is stable when it has got 2 electrons in the outermost shell, and these are 2 that you can see. Does that make sense? Okay, so this is the structure for water. And then the other structure you need to understand is for carbon dioxide. Now carbon dioxide, you have got carbon, it has a double bond to oxygen, another double bond to oxygen. So carbon dioxide has got 2 double bonds with oxygen. Now carbon has a proton number of 6, meaning that its electron configuration is 2, 4. And then oxygen has got a proton number of 8. Its electron configuration is 2, 6. So when you're writing carbon dioxide, we are going to have carbon on the middle, and then we are going to have 2 oxygens. Oxygen on this side, and then oxygen on this side. I'm also going to write a key. Let me say a dot. I'm going to be using it to represent carbon, and then a star, I'm going to be using it to represent oxygen. Now remember, between carbon and oxygen there's a double bond, and carbon has got 4 electrons in the outermost shell. I'm only showing the outermost shell, so I'm going to put 2 here, 1. Carbon, I'm using a dot. the first electron, second electron, and then the other two electrons I'll put one here, then one here. Now I'm going to go to oxygen. Each oxygen has got 6 electrons in the outer shell, so I'll put 2 here, remaining 4. I'll put 2 here, and then I'll put 2 here. Same way with this other oxygen this side, I'll put 2 here, remaining 4. I'll put 2 here, and then I'll put 2 here. So if you count the number of electrons for carbon, 1 2 3 4 5 6 7 8, there are 8 altogether. Same with oxygen, but this is a double bond, this is also a double bond, so that makes the two double bonds which are in carbon dioxide. Is this good? Okay, so this is covalent bonding. You can see it involves the sharing of electrons. Now let's talk about ionic bonding. Ionic bonding, on the other hand, it will not involve the sharing of electrons, but it will involve the gaining and the losing of electrons. And it happens between a metal and a non-metal. Let's say we have got sodium, which is a metal. It is reacting with chlorine, which is a non-metal. How do you tell the formula? You are going to look at the valency. Sodium is in group 1, meaning that it has got a valency of 1, the combining power. Chlorine is in group 7. What is the valency? It's a 1. We said you subtract from 8, isn't it? So when you are forming sodium chloride, those numbers are supposed to exchange. So the product will just be sodium with a chlorine, like that, sodium chloride. Now to write the structure, if they ask you to draw now the way sodium can react with chlorine to form sodium chloride. Sodium, let's look at the outermost shell. Okay, the first thing is you need to know the electron configuration for this sodium and for the chlorine. Let me just check the periodic table to just tell the proton number. Sodium, the proton number is 11. Chlorine should be a 17. So meaning that sodium, the electron configuration is 2, 8, 1, isn't it? And then chlorine is going to be 2, 8, 7. So which one do you think is easy to do? Chlorine, is it going to lose 7 electrons or gain 1 to reach 8? How about sodium? Is it easy to lose 1 or to gain 7 to become 8? To lose, yes. So that is what happens. So for these reactions to happen, I'm going to only show the outermost shell. All right, only the outermost shell. So this is going to be my sodium. It only has 1 electron in the outermost shell. For sodium, I'm going to use let me use a dot. And never forget to write the configuration, because I'm only showing the outermost shell, 2, 8, 1. And this one is reacting with chlorine. I'm also only showing the outermost shell, but I'm going to use a star. It has got 7 electrons in the outermost shell. So the first one is here, 1, 2, 3, 4, 5, 6, 7. The configuration for this one is 2, 8, 7. Now what happened is that the sodium will be able to lose that 1 electron that you can see. So what will remain is that this is gone. So the outermost shell will now remain with 8 electrons. So we are going to see 1, 2, 3, 4, 5, 6, 7, 8. Like this. This is going to be our sodium. But now the electron configuration is now 2, 8. And so you put it in brackets like this, which are square. Because it has lost 1 electron, you are going to show the charge. Every time something loses, it becomes positively charged. And then for the chlorine, the outermost shell, remember, I had 7 stars, but that one electron that has come from the chlorine is going to come here, so it has now gained that one electron. So because it has gained, you put a negative on top, and now the new electron configuration for sodium, I mean for this is chlorine with a minus charge. This one is having a positive because this one was neutral. So the configuration is now 2, 8, 8. You can see the outermost shell is having 8 electrons, the outermost shell is having 8 electrons, meaning that this is now stable. Okay, is this okay? Okay, so this is how we're going to be able to write this structure. Let's just do one more example. Let's say we are talking about, we've been told that magnesium reacts with chlorine and you form magnesium chloride. The first thing is, what will be the formula for magnesium chloride? Now magnesium itself has got a valency of 2, and the reason as to why it has a valence of 2 is because magnesium is in group 2. Okay, magnesium is in group 2. So group 2 meaning a valence of 2. Chlorine is in group 7. So what is its valence? Okay, it has a valence of 1. So when you are forming now the compound magnesium chloride, what you are going to see is that these two numbers are going to be able to swap. Magnesium is going to have a 1 down here, chlorine is going to have a 2 down there. Now this is going to be, you don't show a 1 when you are writing these structures, so simply write it as magnesium chloride like this. Does that make sense? You can see the way the structure is, isn't it? Okay, so just a moment, I just connect it. Okay, So this is our magnesium chloride here. Now magnesium has got a proton number of 12, meaning that its electron configuration is 2, 8, 2. And then chlorine has a proton number of 17. Its configuration is 2, 8, 7. So the meaning of this is that, look at this. You have got a 2 here. What does that mean? It means that magnesium will lose 2 electrons. And if it loses those 2 electrons, where are they going to go? Because chlorine can only take 1, meaning that you need 2 chlorines to take up those 2 electrons. That's why we are having this formula. It means that for magnesium, 1 magnesium will react with 2 chlorines. So I'm only going to show the outermost shell again. So how we're going to write this is, for chlorine it's like this. I'm going to put a 2 in front because we are using the 2 of them. And then I'm going to use dots. Remember, chlorine has got 7 electrons in the outermost shell. Like that. And this is going to react with magnesium. And for magnesium, it has got 2 electrons in the outermost shell. And those 2, let me show them as dots. Don't forget the configurations is 2, 8, 7. This is 2, 8, 2. And then when this reaction happens, magnesium will be able to lose those 2 electrons. And so it will only remain with these 2 electrons which are there. So the configuration will become 2, 8. So I mean it will remain with 8, right? In the outermost shell now. And then those 2 electrons which have gone, so this one is now going to have a charge. It will be magnesium 2 plus. So we'll show the charge on top here, positive 2. Each chlorine is going to gain 1 electron. So I'm going to have 1 chlorine this side, and you're also going to have another chlorine this side. Remember, each one had 7 stars. The 8th one will be now a dot which has come from magnesium. Same one with this one.